In this lesson, we're going to look at how thermal energy can move from one place to another, and we call the flow of thermal energy heat. So heat is the amount of thermal energy that transfers from one object to another due to a temperature difference. Now, that's a big, long definition, but you guys are all familiar with heat. If you've ever reached out and been burned by something, you know that that hot thing transferred a lot of thermal energy into you. And if you've ever reached out and grabbed something cold, you know that you transfer thermal energy to it. So feeling hot is when you're gaining thermal energy from somewhere else, and when you feel cold, you're losing thermal energy to somewhere else. And we call that flow of thermal energy heat. Heat always flows from hot to cold, always. And that means from high to low temp. Now, we want to think about why. We're going to look at that in just a minute. There's different things that can happen and different methods this can happen, but it always happens the same way. Fast, hot particles collide with slow, cold particles, transferring thermal energy to them. Now let's think about why that would be. Over here I have something that's cold. The particles have forces of attraction, and when they're cool, those forces of attraction are better able to hold them together. So this could be a solid, it could be a liquid, it could actually even be a gas, it wouldn't matter. But these particles are relatively cool, so the forces of attraction are better able to contain them and hold them closer together. Whereas if I have something that is a little bit warmer, then its particles actually vibrate back and forth a little bit more, and the forces of attraction are less able to contain them. And that means when this particle vibrates, it hits that one, and when something gets hit, it starts to move, and so the vibration here increases, and there's this domino effect that increases all the random motions of these particles. And that's what an increase in thermal energy is. It's an increase in the motion of the particles, or an increase in their freedom sometimes. Now, heat flow continues until they're all the same, until the temperature is the same everywhere. Now, that doesn't mean the particles stop moving. It just means that the average temperature or the average motion of every particle is the same, and so we don't get any net change in temperature. The temperature doesn't go up, the temperature doesn't go down. There's three ways this can happen. The way I just drew it right here, where we had one particle hitting another particle, hitting another particle, that is a method of heat transfer that we call conduction. Conduction happens in solids. It could also happen in liquids and gases because particles can touch in liquids and solids. There's convection. This one can only happen in fluids because in order for convection to occur, heated particles actually have to move from one place to another. And then there's radiation. And radiation is actually a form of energy transfer that does not involve particles. And so that's a little bit weird. It's strictly energy and not matter. So first we'll take a look at conduction. Conduction is heat transfer between particles in direct contact. And this is exactly what it sounds like. Heat flows from one particle to the next particle that it's touching to the next particle that it's touching. So some examples of conduction. When you stir a hot drink with a metal spoon, the spoon gets warm. That's because the particles of liquid actually hit the particles in the spoon. This is my spoon, and that causes these particles in the spoon to start vibrating, and your skin detects that increased vibration as heat. Touching anything that's hot or cold, because you're touching it, it's conduction. And so we call these things that allow heat to transfer easily conductors. That one's shocking, right? Conductors conduct. Metals are generally very good conductors of heat, but not everything is. There's insulators, and insulators do not allow things to transfer heat easily. That's why we make spoons out of wood and plastic. When we're stirring something that's hot, we don't want to get burned. Wood and plastics tend to be good insulators, as do things like cotton, and the fiberglass insulation in homes is a good insulator. Air is actually a very good insulator as long as the air can't move. If the air can move, then we're in trouble, because then we can get convection. And this is heat transfer by flowing particles. And so I say flowing or moving particles. And this actually occurs because we get heated particles in one spot that can then float away and join or go to another spot and take their energy or their heat with them. So this occurs because hotter fluids This occurs because hotter fluids are less dense since the particles spread out, so they rise. So if we had a container full of water and there's particles floating all around in here, and we started heating up this side right here, we put some fire underneath there, well, these particles are going to gain that energy, and when they gain, they spread out. And when they spread out, they spread up away from that heat, and that's going to allow these particles to sink in. And so we get this net movement of particles, which we call a convection current. So some examples of this include boiling water. You put water over something hot, and the particles at the bottom heat up and expand and move up, and the particles at the top, which are cooler, then sink down, take that place, and we get this circular current of boiling water. There's also convection ovens, which actually use the air in the oven and a fan to circulate through the heat. Lava lamps, if you've ever seen a lava lamp, it's kind of got triangular shape, and then there's the base on it, and then there's usually a big light bulb down here, and then there's this glob of oily stuff, and it moves around. As it gets heated up, it goes up, and as it cools, it sinks. And then heating and cooling of homes often relies on convection by the flow of hot air around the room. There's also a much bigger scale of this. The Earth itself has earthquakes because the lithosphere is actually free to move on top of the asthenosphere, which is part of the mantle. It's sort of the layer between the lithosphere and the mantle. And there's the very, very hot core of Earth produces some convection currents in the mantle, and the lithosphere floating around on top of that is pushed or pulled in different directions, and when the plates run into each other, we can build mountains and get volcanoes and get big earthquakes. So convection can be as simple as warming up some water to driving the things that make earthquakes happen on Earth. And then the last type of heat transfer is radiation, and this is heat transfer by electromagnetic waves. If you see me write EM, that's electromagnetic waves. And another way of thinking of this is light. Light is a type of electromagnetic wave, although infrared carries more heat than visible light. And what's cool about radiation is it can travel through matter, but it can also travel through a vacuum. Remember, that's empty space. So in order for conduction to happen, things have to touch. In order for convection to happen, a fluid has to be able to flow. In order for radiation to happen, nothing needs to be there, or something can be there. We can have space or we can have matter. It doesn't matter. So radiation is the most common form of heat transfer. The reason you can walk outside and feel the warmth from the sun is because it radiates through space to the earth. Fires and stoves, if you've ever stood next to one of those, there is some convection currents going on in the air, but the more heat that you're feeling is actually due to the radiation of that fire. And you can actually feel your own radiation. If you hold your hand right up next to your cheek, you'll be able to feel the heat coming off your cheek. You are radiating that. And then there's, of course, the nuclear reactions, which also radiate heat, and that's actually what keeps the core of the Earth so hot. There's radioactive materials in there that break down and radiate heat. So when you put something on a stove, you actually see all three heat transfer methods, because you've got this pot on a hot surface, which means you have conduction. You have heat flowing right in there, one particle running into another, and in fact that's conduction between the metal and the liquid that's heating up the liquid. Then the liquid starts to flow around and form currents, and even maybe bubbles away and escapes, so you have convection, and the whole thing radiates heat in all directions. So you have all three methods of heat transfer from just heating a boiling or heating a pot of water.